Hey everyone, welcome back. Today we're diving into a groundbreaking study that's turning sweat into science, literally. Imagine a world where machines can see pain through your skin's electrical signals. Sounds like sci-fi, right? Well, scientists are making it a reality, and I'm here to break it down for you. Pain is tricky. It's not just a physical sensation. It's a mix of biology, emotions, and even social cues. But here's the problem. How do you measure something that's so personal? For years, doctors relied on patients saying, it's a 7 out of 10, but what if you can't talk? Or if you're in so much distress you can't even explain it? That's where this research steps in. The key player: electrodermal activity, or EDA. Think of it as your body's stress diary. When you're anxious, in pain, or even just surprised, your sweat glands kick into gear, changing the electrical conductivity of your skin. It's like a hidden language your body speaks, and scientists are learning to listen. But here's the catch: EDA data is messy. It's not a simple on-off switch. It's a wave of signals that can be hard to decode. So researchers took a clever approach. They didn't just look at one version of the data. Instead, they transformed the same EDA signal into 6 different views, like looking at a painting through 6 different filters. One might show the big picture, another zooms in on quick changes, and others highlight specific patterns linked to stress or pain. Then came the big idea, turning these 6 views into a single, cohesive image. Imagine stacking 6 waveform diagrams into one 224 x 224 pixel picture. This multi-representation diagram is like a visual puzzle, where each piece adds context. And here's where AI comes in, specifically a vision transformer, a type of algorithm that's great at spotting patterns in images. The results: when tested on 65 participants, the system nailed pain detection with over 75% accuracy. But the real win: combining all 6 EDA views gave the best results, outperforming older methods. It's like upgrading from a grainy photo to a high-definition video. More details, more clarity. Why does this matter? For patients who can't communicate, like infants, dementia patients, or those in critical care, this could mean faster, more accurate care. It also reduces reliance on painkillers, a huge win for public health. At its core, this research isn't just about pain. It's about bridging the gap between our inner experiences and the tools we use to understand them. Pain is a silent struggle, but with innovations like this, we're giving it a voice. For years, doctors have relied on patients describing their pain, like asking, "How bright is the sky?" when trying to capture a sunset. It's tricky, right? Some people can't even put their feelings into words. That's where these groundbreaking studies step in, using tools that go beyond words to detect pain through the body's hidden signals. Take this 2016 study. Researchers looked at something called electrodermal activity, those tiny electrical changes in your skin when you're stressed or in pain. They used a technique called time-frequency analysis to track these signals, like tuning into your nervous system's heartbeat. And just a few years later, in 2024, scientists took it further. They trained AI to spot pain in facial expressions, even picking up on micro-expressions we might miss. Imagine a machine learning model that can tell someone's in pain just by watching a video. Fast, accurate, and non-invasive. But pain isn't just in the body, it's in the brain, too. A 2021 study used a technique called FNIRS, which shines light through the skull to map brain activity. They discovered that different types of pain light up specific regions, like a puzzle with pieces that fit together. Other researchers are combining data from videos, brain scans, and even electrical signals to create a multimodal view of pain, like solving a mystery with clues from every angle. Why does this matter? Pain is a huge issue. Overdose deaths from opioids are rising, and without better tools, patients risk either too much or too little medication. These studies aren't just about data, they're about real people. A 2025 pilot even tested if AI could tell the difference between pain from electricity and pressure, a key step toward personalized care. Think about it, a future where a quick scan or a short video could give doctors the clarity they need to treat pain accurately and safely. Of course, pain is complex. No single test can capture its full story. But the progress is huge. From decoding skin signals to training AI to read faces, scientists are building a toolkit that's as innovative as it is compassionate. And who knows? Maybe one day, a simple scan could turn invisible suffering into something we can see, understand, and finally relieve. Thanks for watching. If you want more deep dives into science that shapes our future, hit subscribe. And drop a comment. What other hidden signals do you think our bodies are sending? See you next time.